In this video, we'll take a close look at the world of NTP, Network Time Protocol. And as a quick reminder of where this fits in, here is the TCP/IP protocol stack. And at the application layer, we have various services, including many that we've talked about in a previous set of videos. And one of those services is Network Time Protocol. And I've got a question for you. Do you recall at layer 4 what protocol is being used at layer 4 to support NTP? Is it TCP, or is it UDP, or is it something else? And also, regarding NTP, what is the well-known port at layer 4 associated with NTP? And let me give you a few choices there. Is it 23? Is it 22? Is it 21? Is it 80? Is it 443? Or is it something else? So take a moment right now and let me know which layer 4 protocol from our previous discussions is NTP using. So go ahead and pause the video right now, make your best guess, and then when you're ready, click on resume, and we'll take a look at the answer. And welcome back. So how'd you do? So as far as confirming what layer 4 protocol it uses and what is the well-known port for it, which happens to be none of those, let's go to some log files on this firewall and let's take a look at NTP, and we'll confirm together in the log files the layer 4 protocol and also the well-known port for Network Time Protocol. So this is the dashboard for a little firewall I have here in my studio. It happens to be a Palo Alto Next Generation Firewall, and here it's showing me the top applications. And look at this. Look how often DNS is used. We'll take a look at that here in just a couple videos. And a ton of SSL, which also means HTTPS. So DNS is UDP, that's the layer 4 protocol, and the well-known port for DNS requests is port 53. SSL is TCP at layer 4. The well-known port for HTTPS traffic, whether it's SSL or some flavor of TLS, is TCP port 443. And now the question is regarding NTP, which also based on this output has been used quite a bit. What is the layer 4 protocol and what is the port? So to check that out, we'll go up to monitor and we'll go to the traffic logs on this firewall. And because NTP is used quite frequently, it won't be too hard to find. In fact, I see one right here. So the firewall is telling me it's NTP Network Time Protocol. If we open up the details for that log entry, and I'll maximize that as well. Here are the details. This device at 192.168.1.253 is the device at layer 3 that sourced this packet. That IP address got translated by a NAT/PAT device to the globally routable address of 70.173, etc. And also the initial port that was chosen. Look at this 123 right here. That was also swapped out. So when this request is going up to the server right here, it looks like it came from this IP address and this source port. And this is an NTP server that we were accessing, and that indeed is the well-known port for NTP services. And over here on the left, it shows us that it's layer 4 protocol UDP with the destination well-known port of 123. So to confirm what the layer 4 protocol and port is for Network Time Protocol, it is UDP port 123. Now, I think it's interesting that for this one I just happened to grab was using a source port also of 123. So let's just check just for a moment and look at some other device besides this .253 that's making NTP requests. So what I'm going to do in this output here, I'm going to click on port 123 and then click on the right arrow here to apply the filter. And that's going to show me only traffic log entries where the destination port was 123. And that's going to show me a whole bunch of other NTP requests. And let's go ahead and grab this one, for example, this top one coming from 192.168.1.19. Let's look at the details of that. And look at that. You know what? After 20 plus years of working with networking, I still am consistently impressed and learning new things all the time. And today, it's that the source port for NTP requests appears to use the same port number originally as the actual well-known port. Because when a customer is going like to an HTTP website or HTTPS or making a DNS request, they are going to source their sessions from some high-numbered port, like 22,768 or some other number, and then they're going to send the traffic to the well-known port for those services, TCP port 80, TCP port 443, and DNS would be UDP port 53. We also took a look in the videos regarding application layer services that when we have a DHCP client, the DHCP client is going to source the DHCP discover message from UDP port 68 and send it to the well-known port for the server at UDP port 67. So that's going to be a consistent 68 for the DHCP clients making those requests. So for these services, however, it's going to be some random high-numbered port. And for NTP, which I did not fully appreciate until I looked at this output, with NTP it appears that our clients are sourcing it from port 123 and destined to port 123. So the destination port has to be 123 so that the NTP server who's listening on that port can respond. But also I want to point out here that the source port doesn't have to be 123 because our PAT device swapped out that source port number of 123 for some high port number that it used for the translation. So when that request went out, when the response comes back, the PAT device is going to untranslate all that. It's going to untranslate the IP address back. It's going to untranslate the port number back, and then forward it back to this client at 192.168.1.19. And that's one of the benefits of looking at log files and packet captures, is because the packets aren't lying. The packets are literally showing you what's happening. And by default, most operating systems, client operating systems like Windows and Linux and Mac OS and so forth, they are automatically using NTP in the background. So they're reaching out, talking to NTP servers, getting the time, synchronizing their clocks to that time, and away we go. Now, what is not happening by default is that our network infrastructure devices, like, for example, our routers, if we have a firewall here in the path, our firewalls, or multi-layer switches or access switches, most of our infrastructure devices do not and are not configured by default to use NTP. So let's chat for a few moments about the problems of having incorrect time. So let's imagine that the router thinks it's Friday of a certain date. This switch thinks it's Thursday. This device thinks it's 1999. And this device thinks it's Monday. So they all have basically different timestamps. One of the problems is logging. When they create logging events, they're putting timestamps on those logging events. And so if we went to core 1 and looked at the logs there, and then went to core 2 and looked at the logs there, and then went to the router and looked at the logs there, they're all going to have different timestamps on those logging events. So a possible solution to that would be to have a syslog server where we could train all these devices to go ahead and send their syslog messages over to a centralized server. And then when those logs are received, this syslog server can timestamp as far as when those logs were received. That way we can correlate what happened when in relationship to other devices' log events. But ideally, we'd want to have the correct time on our infrastructure devices and have all that information collected either at some type of a security log system or a syslog system and available for correlation. So typically what organizations will do with their infrastructure devices is they will implement NTP, Network Time Protocol, on those devices. Now, NTP is served up in UTC, Universal Time Coordinated, and then the rest of the world, unless you live in that specific time zone, then the rest of the world is going to be a certain number of hours off, like behind that or in front of that. So, for example, in the United States, in the Pacific time zone that I live in, it is -8 off of UTC. And I think that's during the times of the year where daylight savings time is not in force. So in addition to specifying that you want to get time from an NTP server, we're also going to specify our offset from UTC and also specify daylight savings time so that the clock can be adjusted, 1 hour up or 1 hour back, depending if we're in that daylight savings time or not. So I can tell you this, it'd be a lot easier for IT and synchronization of time and everything else if we just didn't have daylight savings time. But we have it. We've had it for a long time. So we'd want to locally configure our devices to specify when it starts and when it stops, and also specify what time zone those devices are in. Another strategy that I've seen is just to use UTC for all the networking devices, regardless of what time zone you're in. And that way, if you have a company that's around the planet, you have some devices up here and devices down here and devices over here, and they're in different time zones. If all of them are reporting and logging using UTC, that could be a nice, easy way to coordinate all that logging information to find out, what happened first versus second versus third, if they're all using the exact same UTC time. So the decision on to use local timestamps or to use UTC is up to the organization. And in addition to having the logs correct based on having the correct timestamps, other benefits of having the accurate time are going to be an Active Directory, which is rotating and using keys. And so if we have systems that are off, for example, by a day or two, it's possible that their authentication and their encryption services wouldn't work if they're out of sync. Now, in the world of Windows, most Windows devices are going to automatically synchronize with NTP, so in the background, they're taking care of that for us. But for our networking devices, we still could have problems with digital certificates. For example, if we're using digital certificates for authentication, and we'll have a whole bunch of separate videos on VPNs and digital certificates. But if we're using certificates for authentication, and if the cert says it's good between 2021 and 2025, and a device has a clock that says it's 1999, it's going to say, wow, that certificate isn't valid yet. Or a device may have a calendar that's set to 2026, which also would say regarding the certificate that's valid from 2021 to 2025, that certificate is no longer valid because its time range for validity is outside the time range that I currently believe it is. So lots of great reasons to have network time protocol, not only on our end devices and servers, but also on our infrastructure devices. So let me clear off the screen and let's talk about a strategy. What we could do is we could use an NTP server that's publicly available on the internet from a government or from a reliable source, and that could be considered a Stratum 1 or an authoritative NTP server. So the way Stratums work is one's at the top, and then below that you have 2, and then below that you have 3, and then below that you have 4, and that continues. And the lower the number is for the Stratum, think of it like it being closer to the atomic or the reliable time source that has the accurate time. So one strategy might be we could take a router at the edge or a firewall at the edge of our network, and we can synchronize with an NTP server that's at a Stratum 1 or possibly a Stratum 2, depending on who we connect to, and get the time from that reliable source. So let's imagine that we've connected to a level 2 or a Stratum 2 NTP server, and we're synchronizing time. What we could then do is we could go ahead and we could offer the time synchronization services to the rest of our environment. So if R1 is getting time from a Stratum 2 time source, it would then be a Stratum 3 in the case that we wanted to go ahead and serve up time from this router, router 1, to the rest of our organization. So if we are serving up time from R1 to R2, we could go ahead and set up that relationship, and this guy would then be considered a Stratum 4. And same thing with here. R3 would be a Stratum 4. And if a device has multiple NTP sources, and one's set at 2 and one's set at 4, it's going to go with the more reliable or lower Stratum number because that's considered to be closer to the source and more accurate. So up here in the core, we could have this switch as a Stratum level 4, getting time from this router as well, and that could continue. Now for fault tolerance, we probably want to have at least a couple devices at the edge of our network that are getting time from an authoritative source. And that way, if we lose one of our devices, we still have the other device available to provide time to the rest of our organization. So from our networking device perspective, it makes a lot of sense to have 1 or 2 devices that are going out to the internet for fault tolerance. That way, if one goes down, the other one's still up, and then provide the time from those devices internally. Now, we also have that kind of built in if you're using Microsoft Windows Active Directory. And here's what I mean by that. If we have an Active Directory server, and then you have clients who are joined and part of Active Directory, those clients can get their time from the Active Directory server. So the Active Directory server itself can go out to the internet, synchronize time that way, and the other Windows computers that are part of the domain can get their time from the Active Directory server, which also is providing NTP services. And at the very top of the heap, the most reliable clocks are often considered to be like atomic clocks or similar that are tied to reliable sources, which are absolutely on point with the correct time. So that's an overview of network time protocol using UDP at layer 4 with the well-known port of 123. And in the next video, I thought it'd be fun to give you a quick demonstration of implementing NTP on our network infrastructure devices. So we'll do that in the next video. I'll see you there in just a moment. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.